Hello, hello, my dear friends. Anyone is in live? Anyone is in live? Hi, Aniket. Hi, hi. Hi, Sri Ganesh. Hi, hi. Hi, hi, Venkadaswamy. Hi, good evening. Good evening, everyone. Good evening. Good evening, Akshara. Good evening, Venkadaswamy. Good evening, Prashant. Good evening, Joshita. Good evening, Mayan Tyagi. Tyagi. Nice. Good evening, Tanvi. Good evening, Prashant. త్యాగి బికేమ్ స్టూడియస్. చదువు చదువు బిడ్డ అయిపోయాడు మ్యాంగ్ త్యాగి. గుడ్ ఈవినింగ్ అమిత్ దుబే. గుడ్ ఈవినింగ్ కిరణ్. మ్యాంగ్ త్యాగి చదువు బిడ్డ అయిపోయాడు. గుడ్ ఈవినింగ్ సూరజ్. గుడ్ ఈవినింగ్ ప్రశాంత్. రైట్ రైట్ రైట్. గుడ్ ఈవినింగ్ ఆకాష్. అచ్చా. గుడ్ ఈవినింగ్ అంజలి. గుడ్ ఈవినింగ్ మనీష్. గుడ్ ఈవినింగ్ గుడ్ ఈవినింగ్ గుడ్ ఈవినింగ్. ధన్షుక్ ధన్షుక్ ఇది నీకు యూజ్ కాదు నాన్న. ధన్షుక్ దిస్ ఇస్ ఫస్ట్ ఇయర్. గుడ్ ఈవినింగ్ సుబానా. గుడ్ ఈవినింగ్ యశ్వంత్. వావ్, అడ్వాన్స్ హ్యాపీ బర్త్డే అనికేత్. सर कश्मीर से देख सकते हैं क्या? You can see it from anywhere. It is open for all. It is open for all. Right. Okay. Nana Danshuk, this is evening. ఇప్పుడే లేచినట్టుకున్నావు. నా అనికేత్, నువ్వు ఎక్స్పెక్ట్ చేసింది ఏది ఉండదు ఇక్కడ. ఓకే ఓకే. గుడ్ ఈవినింగ్ సాయి వైష్ణవి. గుడ్ ఈవినింగ్ సాయి వైష్ణవి. when is this starting? Yes, now I am starting. Hi Sri Ganesh. Now my dear friends, now what are the questions I was giving? It will be helpful for you. The content, it will be make you practice for your exam. But don't expect that direct questions of this one only will be appear in your exam. But that is totally, it will be wrong. Okay? Only this is helpful for you or the practice session for your exam only. But the content which we are going to explain, the model of the questions which we are going to do, the many model of the questions, that it will be helpful for your in the exams of your tomorrow. Okay? Now let's start our session. Now we'll go with the first question. Now my dear friends, now for the each question I will give you the only 1 minute. Okay? Each question I will give you the 1 minute. If you know the answer, try to say me the answer and try to choose. If you don't know, give me the question mark. Okay? Now for the, if you are for the JEE mains and if you are for the NEET, or if you are preparing for any other, NCERT is the first priority. Now do stick for the NCERT. Then after that, go for the any reference. Okay? Polls are not there, Nana. Good evening, Nitya. Good evening. Polls are not there, but max to max I can give. No. Now we'll go with the first question. Now, right. Now is the first question is clear? Now is the first question is clear? Right. Now if you know the answer, try to give me the answer. If you don't know the answer, try to give me the question mark. Okay? Now according to the Bohr theory, when the electron moves from the lower to higher energy orbit, then what it will happen? Answer. My dear friends, please, it is this session I was doing you for your sake only. Don't copy or don't do Google or don't see in any chat GPT. Okay? Done. Now, good everyone, good. It will be absorbed. Good. Right. Energy will be absorbed. Right. Energy, what it will happen? Energy will be absorbed. Good. I cannot actually the many of the answers are coming. I cannot see the names. If I was missed anyone names, okay. If I was missed anyone names, don't mind, okay. చాలా ఆన్సర్స్ వస్తున్నాయి నాకు. Now don't subscribe as given the first answer I know. Okay. Now we know, right? If the electron is in the lower energy level, if this electron want to move from the lower energy to the higher energy level, what we have to do? We have to give the energy. That energy, that electron will be absorbed and it will be excited to the higher excited state. Clear? Now energy is absorbed. Clear? By absorbing this energy, this electron will move to the higher energy level. Right. So the answer is 1. Good. Now the students who has answered. I explaining. Mayank I was explaining. Right. Now next question. Now we'll see how many of you will give the question. Actually, I was thinking of to keep the poll, but it is not getting now actually. Now in the next upcoming lives, I will try to give them. Now try to do the next question. Which one of the following expression represent the electron probability function? Electron probability function. Which of them will be correctly define the electron probability of the function? Which of the correct one will define the electron probability function? Aniket is saying 2, Arjuna is saying 2, Aniket is saying 3, Arjuna is saying 2, rest another, Mayank is saying 2. Shailaja is saying 3. Yes. Answer is 3. Good. Everyone, good. The one who is trying. Answer is, it is probability function, right? Probability. The probability function. Now that is 4 pi r square dr and the psi square. 4 pi r and the. Yes. Good. 3. Probability should be always square, because probability should be always in the positive, right? Now if the electron, if it is moving, now here it is showing, this psi is showing that now the probability of finding the electron may be equal to 0, but it should not be negative. So that's the reason the probability should be always in the square. Clear? The answer is 3. Right? The answer is 3. Good. The students who has given the no answer is 3. Clear? Right. Now we'll move to the next question. The m value is not possible for the double dumbbell shaped orbital is. The m value not possible for double dumbbell shaped orbital is. Now what is the answer? Now Sri Ganesh, you are giving answers very fastly. Amit Dubey 3, Tanvi plus 3. Good. Now Subhana 3, Sinjuja 3, Arjuna 3, Sri Ganesh 3, Kartik Chandana 3, Sai Vaishnavi 3, Aniket 3, Adarsh 3. Now Akshara 3, Mayank 3, wow. Suraj 3, Yashwant 3, yes, Adarsh 3, Srinitya 3. Good. 3 is not at all possible for the double dumbbell shape. Double dumbbell is nothing but D, right? D orbital, right? D orbital means L is equal to 2. L is equal to 2 means possible values are -1, -2, -1, 0, +1 and the +2. Right, good, good, good. Good, everyone, good. Right. Venkateswamy, good. Prashant, good. Right. Now next we'll move to the next question. Now the probability of finding the electron in the orbital. Probability of finding the electron in an orbital is approximately. Naina Mayanktagi. Okay, it is enough. Now what is the answer for this one? Probability of finding the electron. What is the answer? %. So what is the answer we'll get? Yes. The probability of finding the electron is maximum, right? So the maximum here, among all the options, the maximum is 95%. Yes, good. Everyone good. One. Good. Aniket good. Yashwant, Akshara, Suraj, Sri Rishita, Arjuna. Right. Nitya. Good. Manish. Gamer. Right. Good. Everyone good. Nice. Now. Right. Good. Suraj, good. Right. Now we'll move to the next question. Because the probability of finding the electron, because electron will not present in orbit. In the orbit, we are having subshell. In this subshell, we are having the orbital, right? In this orbital, the electrons will be present. Clear? Right. Now this is not a place to ask, Aniket, okay? Now the next question. Which one of the following atomic orbital is not directed along the axis? Now, which one of the following atomic orbitals is not directed along the axis? Now, answer is no. Once you cross check. No. Right. Now, which one of the following atomic orbital is not directed along the axis? Not directed along the axis. No. Once you cross check, Suraj has said the correct. No. He is asking not directed along the axis. No, the correct answer said by Suraj. It is dx. No, this is along the axis only, right? Dx square orbital. If you take this as a y and if you take this as a x, dxy orbital will be on the axis itself, right? Along the axis. Which one of the following atomic orbital is not directed along the axis? Right. Now, dz square is also on the axis only, along the axis only. Now, px orbital, if you cross check, if you take this as a x-axis, it is also on the axis only. Right? Now, dxy orbital, if you cross check, now dxy orbital, now the lobes will be present in between the axis, right? Now, the answer was said by only, I was seeing the first Suraj. Suraj has said the answer. Right. These are the orbitals. See, all the orbitals are on the axis only. All the orbitals are on the axis only. The dz square, now px, no, but the dxy orbital is only in between the axis. So don't rush. Okay. Okay. Just try to see the question properly and give the answer. Don't be in hurry. Don't be in hurry to give the answer. We are having the n number of questions. Okay, right. Next one. Is it clear? Now we know dxy orbital, dxy, dyz and dzx. These orbitals, lobes present in between axis. In between axis. Right? Now dx square minus y square dz square lobes present on axis. Right? Clear? No, right. Now the total number of orbital associated with the third shell will be total number of orbitals associated with the third shell will be. Naina Aniket, you too, నువ్వు కూడా టాపర్ అవ్వాలి. ఓకే ఓకే రైట్. Now, right, next question. Now, answer is 4. Total number of orbitals associated with the third shell will be. Hi, Vishnu Teja. Hi. Total number of orbitals associated with the third shell. He is asking for the third shell. Now, answer is 3, right? Third shell, this is n is equal to 1, this is n is equal to 2, and this is n is equal to 3. Now, he is asking the what number of orbitals? 1, 3s, 3p, we are having 3, and 3d, we are having 5. Total 9, right? Third shell, we are having total 9 orbitals. Good. Suraj and Sai Vaishnavi, who has said, and Joshita, Arjuna, Aniket also said, Tanvi also said, Srinitya also said, Mayank Tyagi said 4. Now Sai Vaishnavi, next, who has said, Akshara has said, good. Now Yashwant, once you cross check your answer, next, this echo is coming up. ఇప్పుడు ఓకేనా? ఇప్పుడు ఓకేనా? Is it clear? Now the voice is clear. Is it clear? The voice is clear now. Voice clear ఉందా? Still అలానే ఉందా? For everyone it is same. Clear, sir. Right. Good evening, Janakiram. 7 questions అయిపోయినాయి. Late to class. Right. Now we'll move to the next question. Now azimuthal quantum number of a non-directional orbital is. Now see the question carefully and try to give the answer. Okay, right. Good evening, Janakiram. Good evening. Now, what is asking? Azimuthal quantum number of non-directional orbital is? Azimuthal quantum number of non-directional orbital is? Azimuthal quantum number of non-directional orbital is 0. Good. No. Yashwant, what happened to you? Why you are giving the wrong answers? Good, Subhana. Good, Joshita. Good, Amit Dubey. Good, Sri Ganesh. Good, Sai Vaishnavi. Good, Janakiram. మ్యాంగ్ తాగి 9 ఏడుకలు వచ్చింది. ఫ్రమ్ వేర్ ద 9 came. ఐ గుడ్ అక్షర, తన్వి గుడ్, నిత్య గుడ్, సూరజ్ గుడ్, అర్జున గుడ్. Right. Now non-directional orbital. Which is the non-directional? We know s orbital is a non-directional in nature, right? S orbital is non-directional in nature. S orbital is non-directional in nature, and P and D are the directional in nature, right? Only on the axis we can find the electron. For which one? For the p orbital and the d orbital, only the electrons can be find on the axis. But s orbital, on the all the axes we can get the electron, right? If it is a spherical, we can get the electrons in all the axes like this. Means if the all the axes here the electron getting means that is non-directional nature. That is s orbital. S orbital azimuthal quantum number L will be equal to 0. So answer is 1. I will explain each and every question. I will explain. Vishnu Teja is saying 96. Now, right. Now, we'll move to the next question. Right. We'll move to the next question. The shape of an orbital is decided by. Good, Aniket. But tomorrow's exam, try to don't bring that 0. రేపటి ఎగ్జామ్లో ఆ ఎస్ ఆర్బిటాల్ యొక్క అజిముథల్ క్వాంటమ్ నెంబర్స్ మాత్రం తెచ్చుకోకండి. అనిగేత్, ఎస్ ఆర్బిటాల్ అజిముథల్ క్వాంటమ్ నెంబర్ మార్క్స్ నీకు రాకూడదు. రైట్? నౌ ద షేప్ ఆఫ్ అన్ ఆర్బిటాల్ ఇస్ డిసైడెడ్ బై. Shape of an orbital is decided by. Shape of an orbital is decided by. Shape of an orbital is decided by. Shape of the orbital is Sri Ganesh. Rajashekar, who is this? Rajashekar S means Sri Ganesh only, right? No. Arjuna is saying 2, Mike Tag is saying 3, Suraj is saying 2. Magnetic quantum number will say the orientation of orbitals. It will say about the orientation of orbitals. Good. It will say the angular wave function. Now, shape of the orbitals is decided by the angular wave function. No. Yes, good. Alekya, good. Now, that shape of the orbitals is decided by the angular wave function. This magnetic quantum numbers will be decided the orientation of the orbital. It defines the orientation of the orbital. Good, Nana, good. Everyone clear? Now, Nana, Vishnu Teja, నీ మీద కూడా పడతాయి జోక్లు. ఆన్సర్స్ వస్తలేవు నీ దగ్గర నుంచి. ఏం గూగుల్ ఇంకా చాట్ జీపీటీ షట్ డౌన్ అయిపోయిందా? ట్రై టు గివ్ ద ఆన్సర్స్. నువ్వు కూడా ఆన్సర్ ఇవ్వడానికి ట్రై చేయి. నీకు కూడా చెప్పిన క్లాస్లో నేను ఇవన్నీ ఇక్కడ కూడా చెప్పిన, కానీ ఆన్సర్స్ రాని. ఆన్సర్స్ కానీ అని చెప్పేసి చాట్ జీపీటీని గూగుల్ని స్ట్రెంగ్ చేయకు, దానికి పని చెప్పకు. రైట్. నౌ నెక్స్ట్, ఆర్బిటాల్ యాంగులర్ మూమెంటం డిపెండ్స్ ఆన్. నెక్స్ట్ క్వశ్చన్, ఆర్బిటాల్ యాంగులర్ మూమెంటం డిపెండ్స్ ఆన్. Orbital angular momentum depends on. Good evening, Prashant. Prashanta Chelli. Good evening, Lasya. Good evening. Now, right. Now, try to say me the answer. Orbital angular momentum depends on. Orbital angular momentum depends on. Orbital angular momentum depends on. No, 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 no. No, my dear friends, I am not asking the angular momentum formula. I am not asking the angular momentum formula. I am not asking the angular momentum formula. My dear friends, once again I am saying I was not asking the angular momentum formula. I am not asking the, no, no, no. No, no. Orbital angular momentum. Orbital angular momentum. Orbital angular momentum will be depend upon the n and m. No, orbital angular momentum will be depend upon n and m. No, I know. You are thinking that orbital angular momentum L into L plus 1 h by 2 pi. This is a formula, but he is asking orbital angular momentum will be depends upon the which quantum numbers. It will be depend upon the n and m. Clear? Is it clear? Now, here we know, right? Now already I explained very clearly about this one. Now orbital angular momentum, radial nodes and the angular nodes. Radial nodes and the angular nodes, that the orbital angular momentum will be depend upon the which one? N and m. Not, I was not asking the formula. This is orbital angular momentum formula. This is orbital angular momentum formula. This is, he is asking the orbital angular momentum depends on the which quantum numbers. Now orbital angular momentum. Hello? Is it clear? Wait, I will explain. Wait. Now, here the orbital angular momentum will be depends upon is saying what is the here the n depends. N says what is the n here, what is the L here, and what is the m here? Can anyone? What is the n here? What is the L here? Explaining. Don't worry. I'm explaining here. Now, what is the n here? What is the L here? What is the n here? What is the L here? What is the m here? First you say me. What is the n here? What is the L here? Now, what is the n here? What is the L here? I was explaining. I was asking you n, L, right? Right. One is a n. Now, Principal quantum number, azimuthal quantum number, and the magnetic quantum number, right? Right? Oh, wait. Orbital angular momentum will be depend upon the n and m. No. Actually, sorry. No. The answer is L only. L. Yeah, L only. Sorry. Orbital angular momentum. I thought angular momentum. Right. Correct. L only, not N and M. Sorry. L only. I thought. Hi, Ketan. Hi. Sorry for this one. No, orbital angular momentum will be depend upon the L only, not M. I thought momentum. Right. L. Oh, L. Yes. Okay. Sir, you're wrong. For this one, I was wrong. Okay. Right. Next one. The quantum number which determines the energy of subshell. Okay. Sorry for my end. I was not seeing the question properly. I thought it is angular momentum. Angular momentum, I thought. Okay, good. Now, next question. Now, next question. The quantum number which determines the energy of subshell is the quantum number, the energy of the subshell is determined. The quantum number which determines the subshell is 1 is saying. Read the question twice, sir. Okay, fine. I will read. Okay, energy of the subshell is N is saying. Now once again you cross check the answers. My dear friend, read the question carefully and try to give me the answer. My dear friends, read the question carefully and try to give me the answer. He is asking the energy of subshell. He is asking the energy of subshell. Energy of the subshell. Now the answer you have changed. Now the answer is changing. First you have said the answer. So that's the reason. Read the question carefully. Read the question carefully and try to give the answer. He is asking the energy of the subshell, right? Now energy of the subshell will be decided on the basis of n plus n value, right? N plus L value. Clear? Now here the n plus n value. Right now what is the answer? What is the answer we got? What is the answer? Here the quantum number which determines the energy of subshell. See, 1s orbital and the 2s orbital energy will be decided on the basis of n plus n value only, right? N plus n value only we will decide, right? So the both the n and l, both the n and l, both the n and l, the quantum numbers which determine the energy of the subshell. Is it clear? Yes. Is it clear for everyone? Right. Okay, right. The Aufbau's principle failed to explain the configuration of the elements with atomic number. Good. Now, next one. Next one. The Aufbau's principle fails to explain the configuration of elements with atomic number. Vati, Kala Vati is 3. Arjuna, how come? Now, Prashant, good. Lasya, good. Now, Janagiram, good. No. How come? Aufbau's principle failed to explain the configuration of the elements with atomic number. Aufbau's principle failed to explain the what is the answer you guys got? Good, everyone. Right, the answer is 3. Now, he has failed to explain the, yes, good, 3 only. He has failed to explain the, because it is having the exceptional electronic configuration, right? Exceptional electronic configuration. Yes, good. Everyone, 23 only, sir, 24 only. Exceptional electronic configuration it is having. He has failed to explain why the electron has not filled 4s1, 3d5, right? Argon 4s5, 3d5, right? Now, the azimuthal quantum number and the principal quantum number of the 17th electron are. Right. Now, this is a one nice question. Now, try to say me the answer. Yes, good. Good, everyone, good. Akshara, Anika, who is it? Joshita, Aniket, Yashwant, Suraj, Lasya, Nitya, Alekya, Sri Rishita, Tanvi, next, now right, Anjali, I was seeing them, now the one who are in the live. Now the next question, the azimuthal quantum number and the principal quantum number of the 17th electron are. Sai Vaishnavi has given the one, option 1, good. Who? Joshita has given 1 and Subhana has given 1. What? Next, who? Janakiram has given 1. Suraj has given 2. Sai Vaishnavi has given 1. Ranit Kola has given 1. Oh, Okati. Right. Now, 17th electron, right? 17th electron is nothing but chlorine. 17th electron is nothing but chlorine. Now, azimuthal quantum number and the principal quantum number. L is 1 and N is 3, right? N is 3. Good. Anika, good. Sir, option number 1. Good. Is, you can see azimuthal quantum number and the principal quantum number. No. Principal quantum number. This is chlorine will comes under the N is equal to 1, 1s2, N is equal to 2, 2s2, 2p6, N is equal to 3, 3s2, 3p6 and 3d10, right? But here the 17, ikkadiki 17 electrons అయిపోతాయి కదమ్మా 3p5. So this is principal quantum number N and the azimuthal quantum number L. So 193. Good. Everyone good. The one who has given the answer, good. Everyone. Right. Next question. The orbital with the lowest energy in which an electron with azimuthal quantum number value 3 is. Read the question carefully and try to give the answer. Now the orbital with the lowest energy in which an electron with azimuthal quantum number L value is 3. Okay. Kirtan. Good. Okay. Fine, Kirtan. Okay. Tinnana nin tinnanu. Aniket tinna. Right. So class మీద focus చేయి. Sai Vaishnavi 1. What is asking? The orbital with the lowest energy in which an electron with azimuthal quantum number value 3 is. Sai Vaishnavi has given the first answer. Good. Next, Rajasekhar S. Good. Next one is Suvana. Next one Amit Dubey. Next one Joshita. Next one Sri Rishita. Tanvi. Next one Akshara. Sai Vaishnavi. Good. Next Lasya. Right. Next Janakiram. Aniket. Next Suraj. Next Kolar Anit. Now right. We know, right? Now if the L is equal to 0, that is S. If the L is equal to 1, that is P. If the L is equal to 2, that is D. If the L is equal to 3, that is F, right? Now the lowest, good, Kirtan, good. Now the lowest energy, the first orbital of the 4 is starting from the 4 only. Yes, Sri Ganesh, good. Clear? Now the answer is 4. Answer is 4. Here the lowest energy in which the electron with the azimuthal quantum number n value 3 is. Clear? It is starting from 4f. Next one will be the 5f, right? So this one will have the lowest n plus n value. 4 plus 3 will give you the 7. Right. Next one. Next one. The quantum number n is equal to 3, L is equal to 1, M is equal to plus 1 and S is equal to plus of. Represent the unpaired electron present in. Unpaired electron present in which atom? Which atom? Unpaired electron is present in which atom? The quantum number n is equal to 3, L is equal to 1, M is equal to 1 and S is equal to plus of. Represent the unpaired electron present in. Unpaired electron present in. Sai Vaishnavi is saying 1. Sai Vaishnavi is saying 1. Sri Ganesh is saying 2. Naina Sri Ganesh nu Google lo koduthunnava? Alekia is saying 4. Kolar Anit is saying 2. Ramul Yashwant is saying 4. Sri Ganesh నువ్వు నాకేదో గూగుల్లో చాట్ జీపీటీలో నువ్వు కొడుతున్నట్టు అన్నట్టు నాకు డౌట్ వస్తుంది. సాయి వైష్ణవి is saying 3. No, Joshita is saying 2. 2. Tanvi saying 1. Joshita saying 2. Janakiram saying 2. Akshara saying 2. Aniket saying 2. Suraj saying 2. అదే కదమ్మా n is equal to 3. n is equal to 3 అంటే థర్డ్ ఆర్బిట్. L is equal to 1 అంటే PA కదా. అండ్ ఈజ్ ఆస్కింగ్ అన్పేర్డ్ ఈస్ ప్రజెంట్ ఇన్. అరే మరి అన్పేర్డ్ ఎలక్ట్రాన్ 3p లోనే కదా ఉండాల్సింది. ద ఎలక్ట్రాన్ దట్ అన్పేర్డ్ విల్ బి ప్రజెంట్ ఇన్ 3p మీన్స్ 3p ఓన్లీ 1 electron. This sodium it is having the one unpaired electron in 3s1. Fluorine that one unpaired electron is present in 2p5. Potassium that unpaired electron is present in 4s1. But is asking the unpaired electron that should be present in 3p. That 3p unpaired electron will be present for the aluminium. Not Alekia. Answer is 3p1. The answer is aluminium. Answer is 2. Yes. Answer is 2. Answer is 2. ఆయన అనికేత్ నన్ ఆఫ్ ద ఎబో కాదు. ఆన్సర్ ఈస్ 2 రైట్. చూడండి ఆప్షన్స్ కరెక్ట్ గా చూడండి, చూసి ఆన్సర్ ఇవ్వండి. నౌ ద నెక్స్ట్ క్వశ్చన్. The next question, try to give me the answer. What is the answer? Answer is 4. Is my voice is clear? What is asking? The magnetic quantum number m for the outermost electron in sodium atom is. Sodium atom outermost option number. Are why option number 1 amma? Why you are choosing it as a 4? Endu confuse aitunaru? No. See, sodium, right? That is 1s2, 2s2, 2p6, 3s1, right? Now this is a valency shell. Itla kuda chudandi. Now this is a 1s2. Now this is a 2s2, 2p6, and this is a 3s1, right? This is a 3s1. Now this is the last electron. This 3s1 is the last electron. He is asking for the outermost only. Then the outermost electron for the 3s. Then he is asking the magnetic quantum number. Yes, n is equal to 3, L is equal to 0, and the possible m values are 0 only, right? So the answer is 1. Now the answer is 1. Not 4. No. Here the possible m values for the sodium atom outermost is 0. So the answer is 1. Right. Which of the following quantum number is correct for an electron 4f orbital? Now 4f orbital. 4f orbital. What are the following quantum numbers are correct? What are the following quantum numbers are correct for the 4f orbital? What are the following quantum numbers are correct for the 4f orbital? Answer is 1. Amit Dubey is saying 1. Joshita is saying, Joshita Sri is saying 1. Lasya is saying 1. Sai Vaishnav is saying 1. Arjuna Kirtan is saying 3. Nana, already I explained you. N value should be always greater than n. N value should not be equal to L, and n value should not be less than L. This 2 is not at all possible. In the fourth option, n value and fourth is both are equal. So you can blindly eliminate the option number 3. Blindly you can eliminate the option number 3. Now he is asking for the 4f, right? The 4f means n is equal to 4, L is equal to 3. Now if the L is equal to 3, the possible m values are -3, -2, -1, 0, +1, +2, and the +3. Clear? N is equal to 4, L is equal to 3. Here the m is +4 they have given. It is not at all possible. Here n and L are equal. That is not at all possible. Now here n is equal to 2, but f orbital L value should be 3. This is eliminated. So the leftover option is 1. So this is correct. Clear? It can be 1 and 4. No. How come 4? L value for the 4f orbital is 3, right? Here he given 2. How come the 4? How come the 4 will be possible? L value for the f orbital is 3. but here he has given 2, but that is not at all possible. So the leftover option is 1 only. You have to cross check all the options. If you cross check all the options only, you will get the answer. Clear? They will make you confused by this type of the questions. Is it clear? Right. Good. Okay, right. All right. Next one. The n and l values of an orbital A are 3 and 2, and the another orbital B are 5 and 0. Then the energy of is asking the energy of which orbital is greater than which one? So what is the answer? Answer is 1. Answer is 1. This one is saying the answer is 1. Sir, could you please revise the Balmer series and all those series, please? Those type of the questions are also there. I will revise. Don't worry. Now, answer. Now, right. Now, the n and l value for the atomic orbital, if the orbital A, n plus n value 3 plus 2 is 5. For the B orbital, 5 plus 0 is also 5. Both the A orbital and the B orbital n plus n value is same. Then I explained very clearly. Now, if the orbital whose n plus n value, if it is same, the orbital with the higher n value is having the higher energy. So, B is the more energy than the A. B is more energy than the A. No. If the n plus n values are same, if n plus n values same, now orbital with a higher n value have higher energy. This is very important. Orbital with so the answer is 1. Right. I will explain. Don't worry. I will explain whatever the doubts are. Aniket, you can drink. No problem. Which of the following arrangements of the electron is most likely to be stable? Chepan. Which of the following? Answer is 3. Which of the following? Answer is yes. No, Subhana, no. He's asking the which of the following arrangement is most no. Here he's asking good Vishnuteja, I was seeing for you only. Inka nee answers ostaleva ani chustuna. He is asking stable. Now all are having the equal same size, right? Now this will also give the maximum this is the stability of the orbitals. Yes, 3 only. Answer is 3 only. No. Which of the following arrangement of the electrons is most likely to be stable? 3 is the answer. ఇక్కడ ఆల్రెడీ పేడ్ అయిపోయింది ఎలక్ట్రాన్. ఇక్కడ మోర్ ద ఎలక్ట్రాన్స్ కెన్ బి పేడ్. ఎందుకు అంటే యూ కెన్ సి హియర్ ద ఎక్స్చేంజ్ ఎనర్జీ ఆర్ ఎలక్ట్రాన్స్ కెన్ బి పేడ్. ఇది ఇక్కడికి రావచ్చు. ఈ ఎలక్ట్రాన్ ఇక్కడికి రావచ్చు, ఈ ఎలక్ట్రాన్ ఇక్కడికి రావచ్చు. ఎలక్ట్రాన్స్ కెన్ బి పేర్డ్. ఇక్కడ ఒకటి చూడు, ఇప్పుడు ఇక్కడ ఆల్రెడీ ఇది పేర్డ్ అయిపోయింది. ఆల్రెడీ ఒక ఎలక్ట్రాన్ ఇక్కడికి రావచ్చు, ఒక ఎలక్ట్రాన్ ఇక్కడ రావచ్చు. ఒక ఎలక్ట్రాన్ అన్పేర్డ్ గా ఉంది కదా. ఇది ఈ అన్ని ఎలక్ట్రాన్ ఒకవేళ పేర్ చేస్తే ఆల్ విల్ గివ్ యూ ద సిమెట్రీ ఆర్బిటాల్స్ ఇస్తుంది. సో దట్స్ ద రీజన్ ఆన్సర్ ఇస్ 3. యూ హ్యావ్ టు బి వెరీ కేర్ఫుల్ విత్ దిస్ టైప్ ఆఫ్ ద. ఇక్కడ ఏ ఆర్బిటాల్ స్టేబుల్ అని అడగడం లేదు. విచ్ ఆర్బిటాల్ ఇస్ స్టేబుల్ మనకు తెలుసు, ఫుల్లీ ఫిల్డ్, నెక్స్ట్ హాఫ్ ఫిల్డ్. కానీ ఇచ్చిన ఓరియంటేషన్ లా ఏది స్టేబుల్ అని అడుగుతున్నాడు. ఇక్కడ ఎలక్ట్రాన్లు అన్ని ఫిల్ చేస్తే, పేరింగ్ చేస్తే ఇక్కడ కంప్లీట్లీ ఫిల్డ్ వస్తుంది కదా, అంటే అన్ని సిమెట్రికల్ గా వస్తాయి కదా ఎలక్ట్రాన్లు ఇలా. సో అందుకని ఆప్షన్ నెంబర్ 3 ఇస్ కరెక్ట్. రైట్. నెక్స్ట్, రీడ్ ద క్వశ్చన్ కేర్ఫుల్లీ అండ్ ట్రై టు గివ్ ద ఆన్సర్. అడావిడి బడి ఇవ్వకండి ఆన్సర్, చూడండి అండ్ ట్రై టు గివ్ ద ఆన్సర్. ఇన్ పొటాషియం ద ఆర్డర్ ఆఫ్ ఎనర్జీ లెవెల్ ఇస్. The potassium, the order of energy level is. The potassium, the order of energy level is. The potassium, the order of energy level is. నానా జానకిరామ్ చూడు ఒకసారి చూసుకో, క్వశ్చన్ చూడు, మంచిగా క్లియర్ గా చూడు. ఏం అడుగుతున్నాడు, ఏ ఆప్షన్ అడుగుతున్నాడు, ఏ ఫర్ విచ్ వన్ ఈజ్ ఆస్కింగ్. Now see the question carefully and try to give the answer. In the potassium, the order of the energy level is. In the potassium, the order of the energy level is. Now Kirtan, answer is 2. Yeah, good. Suraj, ఒకసారి చూసుకో. Now answer is 2. Good. Akshara, Sai Vaishnavi, Tanvi, Kirtan, Amit Dubey, Chandana, Sai Vaishnavi. Right. Aniket sir, when the class, when ఏమో తెలియదు, I don't know. Max to max I will finish it by the 7 or 7:15. క్వశ్చన్స్ అయిపోయినట్టే. ఆల్రెడీ దిస్ క్వశ్చన్ నెంబర్ 21 ఇస్ రన్నింగ్. 21 19 or 20 క్వశ్చన్ రన్ అవుతుంది. విల్ ఫినిష్ వెరీ ఫాస్ట్లీ. రైట్, ఆన్సర్ ఇస్ 2. ద ఆన్సర్ ఇస్ 2 బికాస్ వి నో రైట్ 4s అండ్ ద 3d. 4s n plus n value is 4 and the n plus l value for the 3d is 5. So the first electron will go into the 4s, then after that it will go to the 3d, right? కీర్తనే, అనికారెడ్డి, ఐ సెడ్ అది కీర్తననే చెప్తున్నా, నేను కీర్తననే చెప్తున్నా. కేతన్, ఓ సారీ కేతన, ఓకే ఫాన్, సారీ కేతన్ రైట్. సారీ కేతన్, ఓకే రైట్. ఓకే కేతన్ ఫ్రమ్ నీట్. Arjuna Ketan, you are from mains. Now Ketan from NEET. Okay, right. Next question. మంచిగా చూడండి. Try to give the answer. The number of unpaired electrons of the neutral manganese atom and its divalent anion are in the ratio. Okay. Now one Ketan from NEET, one Arjuna Ketan from mains. Right. Next question. Now try to give me the answer. The number of unpaired electron of the neutral manganese atom and its divalent anion are in the ratio. Now try to say me the answer. The number of unpaired electrons of the neutral manganese atom and its divalent anion are in the ratio. Okay, Ketan. చెప్పండి ఫాస్ట్ గా. ఆన్సర్ ఇస్ 2. ఈజ్ ఆస్కింగ్ అన్పేడ్ ఎలక్ట్రాన్. My dear friends, he is asking unpaired electrons. Atomic numbers అడుగుతలేడు. నెంబర్ ఆఫ్ అన్పేడ్ ఎలక్ట్రాన్స్ అడుగుతున్నాడు నాన్న. అన్పేడ్ ఎలక్ట్రాన్స్ అడుగుతున్నాడు, అటామిక్ నెంబర్స్ అడుగుతలేడు. రీడ్ ద క్వశ్చన్ కేర్ఫుల్లీ. ఈజ్ ఆస్కింగ్ ద అన్పేడ్ ఎలక్ట్రాన్స్. అన్పేడ్ ఎలక్ట్రాన్స్ అడుగుతున్నాడు. The number of unpaired electrons of a neutral manganese atom and its divalent anion are in the ratio of అని అడుగుతున్నాడు. రేషియో ఆఫ్. గుడ్ గుడ్. ఎవరెవరు చెప్పినారు ఆన్సర్? ఫస్ట్ లాస్యా చెప్పింది, గుడ్. తర్వాత నెక్స్ట్ సూరజ్ కాదు, తర్వాత లాస్యా 1 అని చెప్పింది. యశ్వంత్ 22 అని చెప్పినాడు, కాదు. సాయి వైష్ణవి 3 అని చెప్పింది, కాదు. కార్తిక కాదమ్మా. అర్జున 2 అని చెప్పినాడు, కాదు. ఈజ్ ఆస్కింగ్ అన్పేడ్ ఎలక్ట్రాన్. అన్పేడ్ ఎలక్ట్రాన్స్ అంటే తెలుసు కదమ్మా, మ్యాంగనీస్, రైట్? మ్యాంగనీస్ అన్పేడ్ ఎలక్ట్రాన్స్ ఎన్ని? మ్యాంగనీస్ దట్ ఈస్ ఆర్గాన్ 4s2 3d5 కదా, 4s2 3d5. Then the 4s2 3d5 means its number of unpaired electrons are any 4s2 lo completely filled. Now the leftover electrons 5 here, right? In the manganese the number of unpaired electrons are 5. Then he is asking in the divalent, in the Mn, number of unpaired will be equal to 5. Then Mn plus 2 is asking. Mn plus 2 the electronic configuration. Normally 4s2 3d5 is the neutral manganese electronic configuration. After removing the 2 electrons, that electron should be removed from the valency electron, right? Then after removing the 2 electrons, leftover will be the 5 only, right? Again 5 only. Ratio is asking. So 5 and 5, that is equal to 1:1. So the answer is 1. Answer is 1, right? Why you are getting confusion? No. Meaning of divalent means by the removal of 2 electrons. ఇక్కడ ఇచ్చాడు కదా, atomic number manganese is 25 and it loses 2 electrons to form the divalent anion. ఇక్కడ ఇచ్చాడు కదా, 2 electrons లాస్ అయిన తర్వాత divalent anion గా ఫామ్ అవుతాడు. By the loss of 2 electrons it will form the divalent anion. ఓకే. ఇక్కడ 5 unpaired, ఇక్కడ 5 unpaired కదా, 5:5. that the ratio అడుగుతున్నాడు కదా, 1:1. 1. The answer is 1. Good. Right. Next question. 1:2. Now is not the electronic configuration of. ఈ electronic configuration దేనిది కాదు అని అడుగుతున్నాడు. ఓకే రైట్. No, already I explained very clearly. Valency electrons will be removed from the. ఎప్పుడైనా గుర్తుపెట్టుకున్నామా, electrons, already I said electrons should be removed from the valency electrons. Now ఇదేది, ఈ electronic configuration దేనిది కాదు అని అడుగుతున్నాడు. Ketan is saying 4, Vishnu Teja is saying 2. దేనిది కాదు అని అడుగుతున్నాడు. ఈ ఎలక్ట్రానిక్ కాన్ఫిగరేషన్ దేనిది కాదు అని అడుగుతున్నాడు. అమిత్ దుబే సేయింగ్ 1, సూరత్ సేయింగ్ 1, విష్ణు తేజ సెడ్ 2 రాంగ్, కేతన్ సెడ్ 4 రాంగ్, లాసియా సేయింగ్ Fe+3. ఈ Fe+3 ది ఎలక్ట్రానిక్ కాన్ఫిగరేషన్ ఇదే కదమ్మా. యశ్వంత్ ఇస్ సేయింగ్ 3, అది కూడా ఆన్సర్ ఇస్ 1. Mn+3 దాంది కాదు. Mn+3 అంటే నార్మల్లీ Mn will have electronic configuration argon 4s2 3d5 కదా. Now 3 electrons we have removed, Ms+3. If the 3 electrons means 2 electrons should be removed from the S and 1 electron should be removed from the D. If the 1 electron you remove from the D, now this is up to here, this is argon electronic configuration. ఇది ఆర్గాన్ ఎలక్ట్రానిక్ కాన్ఫిగరేషన్ కదా. దెన్ Mn+3 కి ఆర్గాన్ 3d4 ఉండాలి. ఇట్ షుడ్ బి ద ఆర్గాన్ 3d4, బట్ వీఆర్ హ్యావింగ్ విచ్ వన్? ఆర్గాన్ 3d5. ఆర్గాన్ 3d5. ఆర్గాన్ 3d5, రైట్? నౌ Fe+3. Fe+3 నార్మల్ గా Fe. See, I got to know that you are having some confusion in the removal of electrons from the valency shell. ఇక్కడ నేను చెప్తా. Now, what does it mean? Means here if this is a nucleus, now here is the n is equal to 1. Here this is a n is equal to 2. Now here this is a n is equal to 3. Now this is n is equal to 4. Right? Now if I write the electronic configuration for the iron, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and we are having the 3d6. This is the valency electron. We know, right? This is the valency electron. From the last valency electron only we have to remove. After the valency electrons, after the removing of the electron, next we have to remove the electrons from the D. Clear? అంటే ఇప్పుడు Fe+3 లా 2 electrons ఇక్కడ నుంచి పోతాయి, 1 electron ఇక్కడ పోయింది అంటే సేమ్ కదా. 1s2, 2s2, 2p6, 3s2, 3p6, 3d5. ఇప్పుడు Cr+ కి ఎట్లా? ఆర్గాన్ 4s1, 3d5 కదా. Now if you remove 1 electron from here, this is up to here, this is argon electronic configuration only. Argon 3d5 కరెక్ట్ మ్యాచ్ అవుతుంది. ఇక్కడ కోబాల్ట్ ఏంది? 27 కదా. 27 అంటే 4s2, 3d7. ఇక్కడ 3d7 ఉంటుంది. ఇక్కడ 2 రిమూవ్ చేస్తే ఆల్రెడీ మళ్ళీ అదే వస్తుంది కదా, అంతే కదా, 4 electrons. సో ఆన్సర్ ఇస్ 1. ఎందుకు కన్ఫ్యూజ్ అవుతున్నారు? ఎప్పుడైనా గుర్తుపెట్టుకోండి, ఇఫ్ ద ఎలక్ట్రాన్ వాంట్ టు రిమూవ్, that first electron should be removed from the 4s, then only you have to go it for the D. So the answer is Mn+3. Clear? This type of the questions only mostly they will stress. Valency electron should be removed first, then only after that we have to go to the remaining electrons. Clear enough? Still you are having any confusion? Still you are having any confusion, or is it clear? Right? Now we'll move to the next question. Which of the following has maximum number of unpaired electrons? ఇప్పుడు కరెక్ట్ చెప్పండి ఆన్సర్. Now you say me the answer correct. ఇప్పుడు కరెక్ట్ ఆన్సర్ చెప్పండి. ఇక్కడ ఏమడుగుతున్నాడు? which of the following having the maximum number of unpaired electrons? Right. Which of the following is having the maximum number of unpaired electrons? Okay, good. Which of the following having the maximum number of unpaired electrons? Lasya is saying 1. Ketan is saying 2. Sri Ganesh is saying 2. Akhil is saying 2. Suraj is saying 2. Lasya is saying 2. Chandana is saying 2. Tanvi is saying 2. Yashwant is saying, yes. Zn electronic configuration is 4s2, 3d10, right? Argon. Then there is no any unpaired electron. Unpaired electrons are 0. Now when it comes to the Fe+2, it is argon 4s2, 3d6. By the loss of 2 electrons, 3d6, we are having 1, 2, 3, 4, here 5, and here it is 6. So in the Fe+2, the number of unpaired electrons we are having it is 4. Then Nickel+3, here it is a argon 4s2, 3d8. Now 3d8 means now 1, 2, 3, 4, 5, 6, 7, 8. Now 3, right? One electron should be removed from the, two electrons should be removed from the valency electron, and one electron should be removed from the, now D. Then the maximum number of unpaired electrons for the Ni plus 3 is 3. Now Cu plus 1. Cu plus 1 normally electronic configuration, it is having 4s1, 3d10, right? Now one electron if you remove, that should be removed from the S, and the leftover here the Cu plus is having the 0 unpaired electron. So the maximum number of unpaired electrons is Fe plus 2, the answer is 2. Okay? No, here 0. Ikkada 0, zinc is having 0. Zinc is having 0, Cu plus is having 0. Fe plus 2 it is having 4, and Na plus 3 it is having 3. Right, is it clear? Now next, the successive elements belong to the 3D series have the same number of electrons in the D subshell. Then the elements are, ఏం అడుగుతున్నాడు, D block elements లో దేనికి సేమ్ నెంబర్ ఆఫ్ D ఎలక్ట్రాన్స్ ఉంటాయని అడుగుతున్నాడు. In which the D electrons will be same. In which the D electrons will be same. Answer 3. Good. Answer is 3. Right. Answer is 3. Good. Answer is 3. Because here the chromium it is having the exceptional electronic configuration, right? That is argon 4s1 3d5. Now Mn argon 4s2 3d5 is asking in which the same number of electrons will be present in Cr and the Mn. Right, Cr and the Mn, it is having the same number of electrons. Right, good. Next one, which one of the following set of the quantum number is not possible for the 4p? Next is asking which one of the following set of quantum number is not possible for a 4p electrons. For the 4p electrons, which of the following set of quantum numbers is not possible? What is the answer? What is the answer? Answer? Saying everyone is saying 3, 2, some is saying 3, some is saying 2. Suraj is saying 3, Joshita is saying 3, Chandana 3, Ranit saying 2, Amit Dubey 3, Lasya saying 2. He is asking which of the following set of quantum numbers is not possible for the 4p electrons. 4p. Here the n is equal to 4, L is equal to 3, and the possible L is equal to 2, the possible L values. Now here you can see if the n is equal to 4, now the possible L value should be 1, for the p orbital possible L value should be 1. Clear? And the L value if it is 1, now m value should be -1, 0, +1, but here he has given 2, so that it is not at all possible. So option number 3. This actually here he has given 2, so that is not at all possible. Right? So the answer is right. Now we'll go to the next one. Next question. Answer it. The total number of electrons present in the s orbital of all p orbitals and the d orbitals of the cesium ion or cesium ion are respectively. Is asking the ion, cesium ion is asking. My dear friends, try to be very careful with this one. He is asking for the cesium ion, not for the cesium atom. Cesium ion is asking. For the cesium ion is asking. So read the question carefully and try to give the answer. Cesium ion, right? But cesium, we know here helium, neon, argon, krypton, xenon, radon, OG, right? Now here hydrogen, lithium, sodium, potassium, rubidium, and this is a cesium. Now here is a 2, here it is a 10, here it is a 18, here it is a 36, here it is a 54, right? Here it is a which one? Here it is a 86 and here it is a 118. Now here, now in this is asking the cesium ion, right? By the loss of one electron, cesium ion. Cesium ion means indirectly is asking the how many electrons are present in the xenon. This is 2, this is first one, this is second period, this is a third period, this is a fourth period, and this is a fifth period, right? Fifth period. Now here the 2 electrons will be there, here the 2 electrons, here the 8 electrons, here the how many? 8 electrons, here the 18, here the 18. Clear? Now here up to here 2 electrons, here the 2 electrons, here the 2 electrons, here the 2 electrons. Clear? Now 2, 4, 6, 8. In the S, 8 electrons should be there. Then after that, next, then after that, here the P will come. Up to here it is 6. Here it is 6. P, 6 plus 6, 12. And here 6. 12 plus 6, 18. 18 plus 6. 18 plus 6, that is 24. P should be 24. And here the from the fourth period D will come. And the fifth period D will come. Here D10 and the fourth period D10 and the fifth period D10. D should have the 20, right? And D should have the 20. Is asking S orbital, P orbital, and the D orbital. For the cesium ion is asking, right? Cesium ion. Oh, incorrect only. Answer 2 or 3. Oh, here also 2, right? Here also rubidium. For the rubidium also 2. Total 10. Right. Here the 10. 10, D20 and P24, right? Answer is 2. Answer is 2. Not 3. Answer is 2. Answer is 2. You can see here. First one, this is S. This is S. 2 electrons in the S. Now, ikkada group 1, group 2. No. Here you can see, why you are getting confusion. Answer is 2. Why? Because here the 1 S electron, here 1, here 2. Helium also 1s2, right? So 2. Here the lithium, beryllium. Next to sodium, here magnesium. Here the potassium, here which one? Calcium. Here the rubidium, beryllium, magnesium, calcium, strontium. Here the cesium, here it is a which one? Barium. Now you can see, ikkada 2, ikkada 2, 4, ikkada 2, 6, ikkada 2, any 8, ikkada rubidium, strontium, ikkada 2. Arey, chepta inand. He is asking for the, listen carefully, he is asking for the how many electrons or electronic configuration adugutunnadu reverse lo. Ce plus ion ka adugutunnadu. సిఈ అటామిక్ నెంబర్, సీరియం అటామిక్ నెంబర్ 55. ఒక ఎలక్ట్రాన్ తీసేసిన తర్వాత 54 అంటే నథింగ్ బట్ జెనాన్ కి ఎలక్ట్రానిక్ కాన్ఫిగరేషన్ రాయండి. ఎలక్ట్రాన్ కాన్ఫిగరేషన్ ఎస్ లో ఎన్ని, పిలో ఎన్ని, డిలో ఎన్ని అడుగుతున్నాడు. క్లియర్? దిస్ ఈస్ హీలియం. ఇక్కడ ఇదేంది నియాన్, ఇక్కడేంది ఆర్గాన్, ఇక్కడేంది క్రిప్టాన్, ఇక్కడేంది జెనాన్. క్లియర్? వెయిట్ అదే చెప్తున్నా వినండి. లిజన్. ఓకే, నెక్స్ట్ వన్ here it is a hydrogen. Next one, here it is a lithium, here it is a sodium, here it is a potassium, here it is a rubidium. Clear? Here it is a cesium. Done. Is cesium or cerium? He is asking for cerium or cesium? Cesium only. Cesium only. ఓకేనా? రైట్. ఇది కదా ఇక్కడ రెడ్ ఆన్. ఇప్పుడు ఇక్కడ ఏం అడుగుతున్నాడు, సీసియం నుంచి ఒక ఎలక్ట్రాన్ తీసేస్తే అది జెనాన్కే కదా ఎలక్ట్రానిక్ కాన్ఫిగరేషన్ వచ్చేది. ఇట్ విల్ కమ్ టు ద జెనాన్ ఓన్లీ కదా. మరి ఈ జెనాన్ లో ఎన్ని ఎలక్ట్రాన్స్ ఉన్నాయి అని అడుగుతున్నాడు. ఎన్ని ఎలక్ట్రాన్స్ ఎస్ లో ఉన్నాయి, ఎన్ని ఎలక్ట్రాన్స్ పిలో ఉన్నాయి, ఎన్ని ఎలక్ట్రాన్స్ దేంట్లో, ఎన్ని ఎలక్ట్రాన్స్ డిలో ఉన్నాయి అని అడుగుతున్నాడు. క్లియరా? అది ఎలా రాస్తాం ఇప్పుడు చూడండి. ఒకవేళ సీసియం ఎలక్ట్రానిక్ కాన్ఫిగరేషన్ నేను రాయాలి అని అంటే మీకు ఇదంతా కన్ఫ్యూజ్ అవుతుంది అంటే నేనేం రాయాలి, సీసియం ఎలక్ట్రానిక్ కాన్ఫిగరేషన్ రాయాలి. సీసియం ఎలక్ట్రానిక్ కాన్ఫిగరేషన్ ఎట్లా రాయాలి? ఇప్పుడు ఏంది అటామిక్ నెంబర్ 55. 55కి ఎలక్ట్రానిక్ కాన్ఫిగరేషన్ రాయాలి. 55కి ఎలక్ట్రానిక్ కాన్ఫిగరేషన్ ఎట్లా రాస్తాం? ఫస్ట్ ఈస్ 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, తర్వాత 4p6, తర్వాత 5s2, తర్వాత 4d10, తర్వాత 5p6, తర్వాత 6s1. ఇప్పుడు ఏం అడుగుతున్నాడు, సీసియం అయాన్ అంటున్నాడు. అయాన్ అంటే ఏంది, ఒక ఎలక్ట్రాన్ ఎస్ లో నుంచి తీసేయాలి కదా, ఒక ఎలక్ట్రాన్ ఎస్ లో నుంచి తీసేయాలి. తర్వాత ఇప్పుడు ఎస్ లో ఎన్ని ఎలక్ట్రాన్లు, పిలో ఎన్ని ఎలక్ట్రాన్లు, డిలో ఎన్ని ఎలక్ట్రాన్లు అడుగుతున్నాడు. ఇప్పుడు కౌంట్ చేయండి. అసలు అటామిక్ నెంబర్ ఆఫ్ సీసియం ఇస్ 55. ఇప్పుడు కౌంట్ చేయండి. ఎస్ లో ఎన్ని ఉన్నాయి, 2, 2 + 2 4, 4 + 2 ఎన్ని, 6, 6 + 2 ఎన్ని, 6 + 2 ఎంత, 8, 8 + 2 10 కదా. ఎస్ లో ఎన్ని ఎలక్ట్రాన్లు ఉన్నాయి, మొత్తం 10. రైట్. నెక్స్ట్ కమ్స్ టు ద పి. పిలోకి రండి. కమ్స్ టు ద పి. పిలో ఎన్ని ఇక్కడ 6, 6 + 6 12, 12 + 6 ఎన్ని, 18, 18 + 6 24 కదా. పి ఈస్ 24. రైట్. నెక్స్ట్ డిలోకి రండి. డిలో ఎన్ని, ఈడ 10, ఈడ 10. డిలో ఎన్ని టోటల్ 20 కదా. 10, 24, 20 కదా. క్లియరా? క్లియర్ అయిందా? ఆర్ స్టిల్ యు ఆర్ హ్యావింగ్ ఎనీ కన్ఫ్యూజన్? Is it clear or still you are having any confusion? Clear అయిందా? Still you are having any confusion? Should I move to the next question? Should I move to the next question? Clear, sir. Right. Next, the correct set of quantum numbers for the unpaired electron in chlorine atom. Next one. Right. Next one. The correct set of quantum numbers of chlorine unpaired electron. Chlorine unpaired electron quantum numbers is asking. Right. Next. Try to say me. ఫాస్ట్ గా చెప్పండి మా ఆన్సర్. ఫాస్ట్ గా చెప్పడానికి ట్రై చేయండి. Now he is asking for the chlorine unpaired electron, right? Chlorine unpaired electron is present in 3p5. Now 3p5 we are having this electronic configuration 3p5. Now for this one is asking the correct set of quantum numbers. N is equal to 3, L is equal to 1, M is equal to either 0 plus 1 or minus 1. Now S is equal to plus half. Now which one is correct? N is equal to 3 minus 1 plus or minus half. Right. So answer number 4. Good, good, good everyone. Good. Answer number is 4. Next one. A transition metal X has electronic configuration 3d4 in its plus 3 oxidation state. Now atomic number is. Good, Nana. Good, good everyone. Good. Now a transition metal X has a electronic configuration 3d4 in its plus 3 oxidation state. Its atomic number is. Its atomic number is. Its atomic number is. Its atomic number is. Is saying 3. Argon 3d4 in its plus 3 oxidation state. Lassia is saying 3. Subhana is saying 1. 3, 3. No, good, good. Subhana, good. Tanvi, good. Answer is 25. He is asking, we know normally atomic number 25 is manganese, right? Manganese means argon 4s2 3d5. But is asking after the removal of the 3 electrons. Now that should electronic configuration should be have the argon what 3d4 is saying. Then if you remove the 3 electrons, already I explained it very clearly. First 2 electrons should be removed from the S and 1 electron should be removed from the D. Then if the 1 electron if you remove from the D, then this is the electronic configuration, right? That is 3d4. So the answer is 1 atomic number. If it is atomic number 26, now you see if it is a Fe plus 3 oxidation state. Now this is potassium plus 3 and here this is a titanium plus 3. Titanium plus 3 oxidation state will be argon 3d1. Now potassium plus 3 oxidation state, here it will move to the which one? Neon it will move to the which one? After the loss of 3 electrons it will move to the which electronic configuration? Sulfur electronic configuration. Sulfur electronic configuration will be 3s2 3p4. Then this one will be the argon which one? 3d5. So according to that one answer is 1. Right. Next one. Which one of the following ions has same number of unpaired electrons as those of V plus 3 ion? Which one of the following ion has the same number of unpaired electrons as those present in the V plus 3 ion? In the V plus 3 ion, how many unpaired electrons are there? Among this one, in which one the unpaired electrons will be there? The same unpaired electrons which are present in the V plus 3 ion. Now the same unpaired electrons will be present in. No. Kadu. Answer adi kadu. Yes, Ketan answer is 2. Right. ఇక్కడ చూడండి అమ్మా V plus 3 అంటే argon. Normally vanadium electronic configuration is 4s2 3d3 కదా. 4s2 and the 3d3. In this 4s2 3d3 V plus 3 ion కదా. V plus 3 ion అంటే 2 electrons should be removed from the valence electron and 1 electron should be removed from here. 1 electron should be removed from here. Then here the argon 3d. Here it is having the one exceptional what? Here we are having 3d2. Means the number of unpaired electrons are 2 here. Here the number of unpaired electrons are 2. Then when it comes to the nickel, nickel it is having the argon 4s2 3d8, right? Or 3d8 we are having 1s2 here 3d8 electrons, we are having the 2 unpaired electrons, that it is matching to the V plus 3 ion. So the answer is 2. Clear? The answer is 2. You have to be very careful with this one. Next one. What is asking here? No. A compound vanadium has a magnetic momentum of 1.73 Bohr magnetons. The electronic configuration of vanadium is having the what magnetic moment is 1.73. The electronic configuration of that vanadium ion is asking. Sai Vaishnavi is saying 2. Joshita is saying 2. Now what is the answer? Now Lasya is saying 2. Good. Now here the vanadium, if it is in the plus 3 oxidation state, its electronic configuration is 4s0 and 3d how many? 3d 2. Clear? Now vanadium, it is having the 4s2 and 3d3, right? But if it is in the plus 3 oxidation state, it is having the 2. It is having the 2 unpaired electrons. 2 unpaired electrons will not give you the 1.73. So it should have the 3d1 electronic configuration. If it is having the 3d1 electronic configuration, its unpaired electron will be 1. Now that unpaired electron mu is equal to root n into n plus 2 Bohr magnetons. Then here the 1 plus 3. So root 3 approximately will give the 1.73 Bohr magnetons. So the electronic configuration is 3d1 4s0. So the answer is 2. Right. Now next one. Now right. First నుంచి explain చేశాను కదా. Right. Next one. Now next question. An element has 2 electrons in the K shell, 8 electrons in the L shell, and 13 electrons in the M shell. The 1 electron in the N shell. The element is కేతన్ ఏమి ఎక్స్ప్లెయిన్ చేయాలమ్మా? ఎక్కడ కన్ఫ్యూజ్ అవుతున్నాను? నేను ఏదైనా క్వశ్చన్ చెప్తే దానికి ఎక్స్ప్లెనేషన్ ఇస్తా. Now he is asking here K, L, M, N. So he is asking Sai Vaishnavi is saying 1. Good Nana. Joshita ఒకసారి చూసుకోమా ఏమంటున్నాడు? He is saying that 2 electrons here. Next ఇక్కడ 1s2 కదా. Next L shell 8, that is 2s2 2p6, 8 electrons done. Here 2 done. Next ఏమన్నాడు? 13 electrons in the M అంటే 3s2 3p6, ఇక్కడ 4s1 ఒక ఎలక్ట్రాన్ ఉంది అన్నాడు. దాని తర్వాత ఇక్కడికి 19 అయిపోయినాయి. ఇక్కడికి 8 అయిపోయినాయి. 8 తర్వాత నెక్స్ట్ ఏమున్నాయి? 8 తర్వాత 13కి రావాలంటే 2 plus 3 అంటే 5, 3d5 కదా. That it will be give to the chromium kada. So the answer is 1. Not 3. Answer is 1. ఇక్కడ ఏమన్నాడమ్మా? Kలో 2, ఇక్కడ 13, ఇక్కడ 1 కదా. Next. Now what is the maximum wavelength obtained for the He plus ion in the Lyman series? Right. What is the maximum wavelength obtained for He plus ion in the Lyman series? In the Lyman series, what is the wavelength obtained? What is the maximum wavelength obtained for the He plus ion in the Lyman series? Right. Now, what is the maximum wavelength obtained for the He plus ion in the Lyman series? Answer 4. Now we'll see. Here wavelength, maximum wavelength is asking, right? Maximum wavelength means nothing but if the energy difference, if it is less, maximum wavelength for Lyman series means he is asking for the first line. N1 is 1, N2 is 2. Then here the wave number is equal to Rydberg constant into Z square. Helium will be the 4. Now the first line will be from the 1 and the second line will be from the 4. Done. Then it will become the wave number will be equal to the R 4 into 3 by 4. Or 4 get cancelled. Now that it will be wave number will be equal to the 3R. Wave number will be equal to the 3R. Then he is asking for the wavelength, right? Now 1 by lambda is equal to 3R for the wave number. Then wave number, if you bring it to here, 1 by 3R is equal to lambda. So the answer option number 2. Option number 2, not 4. Not 4, option number 2. You have to be very careful with this one. It is not the option number. He is asking the maximum wavelength. Maximum wavelength is nothing but now that is from the n is equal to 1 to n is equal to 2. Okay, answer is 2. What are the values of orbital angular momentum? Orbital angular momentum of an electron in orbits of 1s, 3s, 3d and 2p. This h cut is nothing but h by 2 pi. Chappan. Send me the answer. What is the answer? What is the answer? Lassia is saying 2. Formula you know, right? L into L plus 1 H cut. అంతే. ఇక్కడ S ఆర్బిటాల్ కి 0. ఇదంతా 0 అయిపోతుంది కదా, 0 into something 0. ఇక్కడ 3s ఆర్బిటాల్ కి కూడా 0నే. D ఆర్బిటాల్ కి ఎంత 2 కదా, D ఆర్బిటాల్ 2. 2 into 3 6. 0 0 6. 2p కి 1. సో ఆన్సర్ 1. అరే ఎందుకు కన్ఫ్యూజ్ అవుతున్నారమ్మా? ఇక్కడ 3s అడుగుతున్నాడు కదా. 3s is nothing but L value for the s orbital is 0. So root 0 into 0 plus 1 h cut. So it will be 0. Next for the 1s is asking. L value is 0. Same 0 into 0 plus 1 h cut. Again it is 0. Next 3d. 3d L value is 2. Then root 2 into 2 plus 1 it will be the root 3. C3 it will become 6h cut. Then next one will be the 2p. 2p nothing but L is equal to 1. Root 1 into 2. So that will be the root 2h cut. So the option number 1 is correct. ఎందుకంత కన్ఫ్యూజ్ అవుతున్నారు? Don't get confused. Right. Next, among the following configuration is valid for. ఇక్కడ ఇచ్చిన కాన్ఫిగరేషన్ దేనికి వ్యాలిడ్ అవుతుంది? is asking now the among the following configuration 1s2 2s2 2p5 3s1 is valid for. Is valid for. S2, 2s2, 2p5, 3s1 is valid for. Option 1. మంచిగా చూడండి అమ్మా. Good, Subhana, good. Actually, the answer is excited state of neon. 1s2, 2s. Right. No. Actually, not excited state of neon కాదు. Answer is 2. Answer is 2. Excited state of fluorine. Excited state of fluorine. ఇదే కదమ్మా ఫ్లోరిన్ కి ఎంత 1s2 2s2 2p5 కదా normally. Now here is directly that electron has went into the no directly electron has been went to the 3s1. Directly that electron has been at ground state లో fluorine electronic configuration ఇది. Now excited state లో here you know right, electron if it is present in the 2p, now the next higher excited state is 3s only, right? Higher excited state is 3s only, so the answer is 2. So excited state of the fluorine అదే కదమ్మా 2p ఆర్బిటల్ లో ఉన్న ఎలక్ట్రాన్ ఎనర్జీ తీసుకొని 3s కి వెళ్ళిపోయింది, బికాస్ దిస్ ఇస్ అ న్యూక్లియస్. n is equal to 1 orbit is having lower energy, n is equal to 2 it is having some higher energy, then n is equal to 3. No, 1 లో ఎలక్ట్రానిక్ కాన్ఫిగరేషన్ ఇంతే కదమ్మా. గ్రౌండ్ స్టేట్ అడుగుతున్నాడు. గ్రౌండ్ స్టేట్ అంటే నార్మల్ లో ఉంది. దిస్ ఈస్ ద గ్రౌండ్ స్టేట్ ఎలక్ట్రానిక్ కాన్ఫిగరేషన్ ఆఫ్ ఫ్లోరిన్ 1s2 2s2 2p5 ఇది గ్రౌండ్ స్టేట్. ఇప్పుడు ఇది ఎగ్జైటెడ్ స్టేట్ కదా, n is equal to 1 లో -13.6 ఎనర్జీ ఉంటుంది కదా, ఇక్కడ -3.4 ఉంటుంది కదా, ఇక్కడ -1.51 ఉంటుంది కదా. ఇక్కడ ఎలక్ట్రాన్ తీసుకొని ఇక్కడ 3s1 ఆర్బిటల్ లోకి ఎలక్ట్రాన్ వచ్చేస్తుంది. సో దాన్ని ఎగ్జైటెడ్ స్టేట్ అంటాం. అదే కదా, ఇది గ్రౌండ్ స్టేట్. గ్రౌండ్ స్టేట్ లో ఉన్న ఎలక్ట్రాన్ ఎగ్జైటెడ్ స్టేట్ లోకి వెళ్ళింది, సో దాన్ని ఎగ్జైటెడ్ స్టేట్ ఆఫ్ ఎలక్ట్రానిక్ కాన్ఫిగరేషన్ అంటాం. Why not excited state of neon? Excited state of neon configuration ఎట్లా వస్తుంది? Oh sorry answer is 3 only. Oh I did not cross check. Sorry answer is 3 only. Excited state of neon. Oh sorry then 2p4 అవ్వాలి కదా. Right. Good. Answer is 3. Sorry. Answer is 3 only. Sorry. నేను నియాన్ చూడలే ఇక్కడ. సరే answer is 3 only. 1s2 2s2 2p6 is the electronic configuration. ఒక ఎలక్ట్రాన్ ఎగ్జైట్ అయిన తర్వాత 3s లోకి పోతుంది కదా, అప్పుడు ఇక్కడ 2p5 అవుతుంది. కరెక్ట్. నియాన్ సారీ. Okay, good. Everyone, the one who has said the answer, I think many of the students have said the answer 3. Okay. Answer is 3 only. Right. I did not check the neon. Excited state of the neon. Right. Okay. Yes, Akshara said the answer. Subhana said the answer. Many of the students have said the answer. Now, yes. Right. Now, fast answer ఇవ్వండమ్మా. Now, we'll try to finish the session. ఇక్కడ ఏం అడుగుతున్నాడు, which of the orbital pictorial representation for psi 2py orbital? Psi 2py orbital. Psi 2py orbital. Yes, my dear friends, yes, Nana, someone, I don't know his name. Whatever the doubt you are having, you can ask. Answer is 3. No, Arjuna is saying 2. Yes, Janakiram is saying 11. Sir, Janakiram is saying 1. No, he's asking for 2py orbital, right? Answer is 2. Answer is 2. Because this is a 2py orbital. 2py orbital means here is nothing but is asking for the 2py orbital. Now we know the orbital that it is present on the axis. Now that's the reason only we are saying this as a py, right? If the orbital, if it is a z, now the lobe will be present on the z axis for the pz orbital. So the answer is 2. Yes, good. Now right. Is it clear? Clear? Now someone is asking the Rydberg constant value. Someone is asking the Rydberg constant value 1097371.6 meter inverse. you can take. Clear? If you want in the centimeters, 1097337 centimeter inverse. Right. We'll move to the next one. Now, next one. Right. Next one. Which one of the following set of quantum number an electron will have the highest energy? Highest energy is asking. Highest energy is asking. Highest energy is asking. So Amit Dubey is saying 2, Vaishnavi is saying 4, Janagram say, Yashwant is saying 4. Yes, answer is 2. Answer is 2. Clear? Answer is 2. Now I think here the n plus n value is 5 plus 0. It is 5. Now here the n plus n value 4 plus 1. It is 5. Here the n plus n value 4 plus 2. It is 6. Here the n plus n value 3 plus 2. It is 5. Now the one which is having the higher n plus n value is having the higher energy, right? So here the 4 plus 2 is having the 6. Now the answer is 2. Good. Right. Sri Ganesh 2. Right. Answer is 2. You have to be very careful with this one. No. ఇక్కడ చూడండి అమ్మా ఎన్ వాల్యూ పెద్దగా ఉంది కదా అని చెప్పేసి ఎనర్జీ పెద్దది కాదు. ఎన్ ప్లస్ ఎన్ వాల్యూ యూ హావ్ టు క్రాస్ చెక్. ఎన్ ప్లస్ ఎన్ వాల్యూ యూ హావ్ టు క్రాస్ చెక్. నెక్స్ట్ వన్. నోడల్ ప్లేన్స్ ఇన్ ద 4D ఆర్బిటాల్స్. నోడల్ ప్లేన్ అడుగుతున్నాడు. నోడల్ ప్లేన్ ఈజ్ నాట్ ఆస్కింగ్. రీడ్ ద క్వశ్చన్ కేర్ఫుల్లీ అండ్ ట్రై టు గివ్ ద ఆన్సర్. నోడల్ ప్లేన్ అడుగుతున్నాడు. నోడల్ ప్లేన్ ఫర్ ద 4D ఆర్బిటాల్. Nodal plane for the 4D orbital. Nodal plane for the 4D orbital. What is the nodal plane for the 4D orbital? Lasya is saying to something, is saying 2R. Nodal plane. Option number 3. He is asking nodal plane kadamma 4D orbital. 4D orbital nodal plane is nothing but angular node. Nodal plane is nothing but angular node. Angular node will be equal to L value. Now for the D orbital L value is 2. So the angular nodes are 2. So the answer is 3. No, answer is 3. Nodal planes is nothing but angular nodes. Nodal planes is nothing but angular nodes. So angular nodes will be equal to L. Angular nodes is nothing but equal to L. Now DL value is 2. DL value is 2. Okay. Good. Shubhana, good. Everyone. It is 2. Right. So. Oh, you are saying 2, so option number 3. Okay, fine. Option, you have to say, right. Next one. He is asking which of the following orbital does not have the angular nodes? Angular nodes. Which of the following orbital does not have the angular nodes? Which one is not having the angular nodes? Say me the option. Don't say the answer. Say me the option. Option cheppandi. Okay, try to say the option. Try to say me the option. Option 1. Yes, good. 2s orbital. Yes, 2s orbital. 2s orbital L value is 0. So its angular nodes are 0. Its angular node is 0. Right. Its angular node is 0. Yes, yes, yes. Right, right, right. Next one. How many number of spectral lines obtained in the visible region? How many number of spectral lines obtained in the visible region if the electron drops from fifth energy level to third energy level? Now, he is asking here if the electron is coming from the అయిపోయినాయి ఓన్లీ ఓన్లీ ఒక ఫైవ్ సిక్స్ క్వశ్చన్స్ ఉంటాయి అంతే. దీస్ క్వశ్చన్స్ ఆర్ వెరీ వెరీ ఇంపార్టెంట్. వినండి ఈ క్వశ్చన్ చాలా ఇంపార్టెంట్ ఫర్ ద టుమారోస్ ఎగ్జామ్. ఇట్ ఈస్ వెరీ వెరీ ఇంపార్టెంట్ ఈ క్వశ్చన్స్. Option number 2. Sai Vaishnav is saying option number 1. How many number of the spectrum of the lines are obtained in visible region if the electron drops from fifth energy level to third energy level? Option number 4. Option number 4. Ayo. Now, should I say the answer? Answer is 0. Option number 3 is correct. My dear friend, may I know your name? The one who is asking the sir, what test is tomorrow? No, option 3, because here the electron is coming from n is equal to 5. Electron is coming n is equal to 4. Electron is coming to the n is equal to 3. Electron is coming to the n is equal to 2. And the electron is coming to the n is equal to 1. Now the electron is coming to the n is equal 5 to 4 means he is asking the visible lines will be false in the Balmer series, right? Here the visible lines will be false under the Balmer series. Now the Balmer series is of the n is equal to 2. But electrons are not coming to the n is equal to 2 only. How the lines will come? He is asking, you can see how the lines will come. In the visible region is asking. In the visible region electrons are only not coming. If the electrons are not coming means how the electrons will come. Now the number of lines are 0. So you have to be very careful with this one. Yes, option number 3. Good. May I know your name? What is that? Kitsuni. Some weird name it is there. So I cannot spell it correctly. You can say your name. Next one. Now, A0 be the radius of the first Bohr orbit of hydrogen atom. The de Broglie wavelength of electron revolving in the fourth orbit will be. The de Broglie wavelength of the electron revolving in the fourth orbit will be. Gyan. Okay, fine, Gyan. Now, Semi. Sri Ganesh. Right. Now say me the answer for this one. What is the answer for this one? What is the answer for this one? Second option. Now we know that if the electron is revolving in the wave in the Bohr orbit, that formula we are having the 2 pi r is equal to n lambda. Then r is equal to 2 pi r is equal to n square by z, and the 0.59 he has taken it as a n, and this is a n and it is a lambda. Here the n and the square will be get cancelled. Then is asking in the fourth orbit. Fourth orbit means for the hydrogen atom it will become 1. Now fourth orbit means here n will become 4. So 2 into 4, 8 pi a naught. So fourth option. Answer is 4. This is clear? This is 4, right? Option number 4. N orbit is asking, right? Fourth orbit is asking. Fourth orbit n value is 4. 2 into 4 it will be 8. Option number 4. 8 pi a naught. 8 pi a naught. Okay? Right. Okay. Next one. Now, the wavelength in the second Bohr orbit made by the electron in hydrogen atom is asking the wavelength in the second Bohr orbit made by the electron in hydrogen atom. Right. Next question. Read the question carefully and try to same type of the model of the question only. In the last question example we have seen, right? The same model of the type of the question only. Now, what the wavelength in the second Bohr orbit made by the electron in hydrogen atom is, where A is the atomic radius of the first Bohr orbit. So here also same formula, 2 pi r, right, that is I am writing it as a radius, 2a naught is equal to n by lambda. Here the n, the square will be get cancelled. Now he is asking of the second Bohr orbit, right? Second Bohr orbit will be 2. 2 into 2 it will be 4. 4a naught, it is option number 1. It is option number 1. No, he is asking for the second Bohr orbit, amma. Second Bohr orbit. Why you are getting confusion? Aniket, you can leave. No problem, Aniket, you can leave. Aniket, you can leave the class. You can leave the class, no problem. Right. Answer is no. You can see 2 pi r means n square by z, right? Radius of an atom formula. N square by z 0.529 is saying it as a, take it as a naught. Then is equal to n lambda. Here the n and the square will be get cancelled if it comes to. Now n is equal to which orbit? Second orbit, right? If you put it as a 2, 2 into 2, 4 pi a naught. So answer is 1. Okay, fine. The how many wave motions of an electron in the Bohr orbit in this hydrogen atom is showing. See here, how many waves, one revolution that electron has been completed. In how many waves? By seeing this picture you have to say me. Seeing this picture you have to say me. The number of waves produced by it will be. Tomorrow in our college we are having the test for our students. So for them I was recapping these questions. Option number 2. Now you can see here how many waves it has made. We'll see here. If it is started from here, this is one wave. Now if it is started from here, now this is a second wave. Now if it is started from here, it is a 3 waves. Means in the orbit it has made the 3 waves. In the one orbit it has made the 3 waves. So option number 2. Right. Option number 2. From here to here, this is a wave. Wave will be represented in this manner only, right? Now here to here, one wave. Now here to here, one wave. Here to here, one wave. Total 3. So option number 2. Right. I hope the picture is clear. I think so. Now he is asking the graph of the probability density versus distance of the electron in the 2s orbital. He is asking the probability density of 2s orbital. Which graph is correct? Which graph is correct for the 2s orbital is asking. Option number 4. Option number 2. Yes, 2s orbital, the radial node formula is n minus L minus 1, right? Now 2 minus 0 minus 1. Here the n is equal to 2, L is equal to 0 for the s. So 2 minus 0 minus 1. So 1 radial node. So 1 radial node for the s orbital, the graph will be start from the origin. Now here the 1 node, and after that it is there. So option number 3. Option number 3. You know, right? For the 2s orbital radial node is 1. 2s orbital, the radial node is 1. Now you can see this orbital here, this is not having the node. It is not having the, actually this is not at all properly, it is having the node. Clear? Next one, here the node it has finished. Here the 1s orbital, the graph will be starts from in this manner, right? First, this is the graph for the 2s orbital. Now this graph, is it clear? Right, it's right. Answer is 3. Now I will explain. Now we'll see how the graph will be. Here for the 1s orbital, radial node will be n minus L minus 1, that is 0. So the radial probability density curve for the graph you will get, it is as a psi square versus r. The graph you will get in this manner. For the 2s orbital, the graph you will get radial node n minus L minus 1 will be 2 minus 0 minus 1 will give you the how many? 1. Now the graph you will get in this manner. In this manner you will get. Sorry. Now the graph you will get in this manner. So the option number C. Ramulu sir, for s orbital it will start from the origin. No, that is radial probability distribution function, it will start from the. This is probability density, it will start from the maxima. Radial probability density means the graph for the 2s orbital. If you want to draw the graph, then the option it should be have the radial probability distribution. Radial probability distribution, it should, the graph will be start from the origin. Now probability density and the radial curve, the graph will be start from the maxima. The wave equation I was given, right? One wave equation. Clear? Now here, right? Done. అయిపోతుంది. Only 2 questions we are having. Now we'll end. Now is calculate the wavelength of the electron moving in the velocity would be. What is the answer for this one? What is the answer for this question? Now say me the answer for this one. ఓన్లీ ఇంకా 2 క్వశ్చన్స్ ఉన్నాయమ్మా. 2 క్వశ్చన్స్ ఉన్నాయి. బై ద 2 క్వశ్చన్స్ వి విల్ ఎండ్. త్వరగా చెప్పండి ఏమంటున్నాడు. వేవ్ లెంత్ ఆఫ్ an electron moving with an velocity would be. Wavelength an electron is revolving. Should I enlarge the question? ఒక 2 క్వశ్చన్స్ ఉన్నాయి, ఇంకొక 2 క్వశ్చన్స్ ఉన్నాయి. 2 క్వశ్చన్స్ చేసేసి ఎండ్ చేద్దాం. Lambda is equal to, we know, right? Now we know the formula, right? Lambda is equal to h by mv. Planck's constant value 6 into 6 10 to the power minus 34. Clear? Now 1 joule is equal to kg meter square per second square. Okay, ikkada kg meter square second inverse square. Done. Tarvata ikkada inkoka second untadi. Done. Next one, mass of the electron will be 9.1 into 10 to the power minus 31 kg. Right? Now velocity em ichiradu 2.05 into 10 to the power 7 meter per second. Right? Meter per second. Ikkada e second square get cancel. kg get cancel. Ikkada meter oka meter get cancel. Done. Then if you calculate, you will get the answer. ఇది క్యాలిక్యులేట్ చేస్తే మీకు వస్తుందమ్మా ఆన్సర్. Right? Still you are having any confusion? Calculate చేసి చెప్పండి ఆన్సర్. What is the answer? Correct answer for it? వచ్చిందా ఆన్సర్? వచ్చిందా ఆన్సర్ గేమ్? The answer came. My dear friends, answer came. Answer వచ్చిందా? Now you can calculate and try to do the answer for it, and we'll move to the next question. Now he's asking which of the following ion has the same radius as first Bohr orbit of hydrogen atom. దేనికి సేమ్ హైడ్రోజన్ బోర్ ఆటమ్ కి రేడియస్ సేమ్ దేనికి సేమ్ అని అడుగుతున్నాడు. మై డియర్ ఫ్రెండ్స్, ఆర్ యు దేర్? ఎనీవన్ ఇన్ ద లైవ్? ఎనీవన్ ఇస్ ఇన్ ద లైవ్? ఎనీవన్ ఇస్ ఇన్ ద లైవ్? I was not getting the options actually. Right. 4.6 into 10 to the power minus 12, you got the answer. 4.6 into 10 to the power minus 12 you got. Okay, you can do. Right, Chapanda. What is the answer for this one? What is the answer for this one? What is the answer for this one? Option number 4. Is asking the first Bohr orbit of hydrogen atom. First Bohr orbit to hydrogen atom ki dentlo same అని అడుగుతున్నాడు. Now if you take it for the first Bohr orbit of the hydrogen atom, radius of hydrogen atom is 0.529 1 by 1. Now if you take it here for this one, radius of He plus ion 0.529 n square by z, right? 4 by 2. It will become 2, but it is not same. Lithium or He plus, that is 0.529. It will be the 4 by 3. It will not be same. Then answer is B plus 3. How? B plus 3. B plus 3 0.529. That is 2 by 4. Sorry, 4 by 4. 4 would get cancelled. So option number 3. Option number 3. Because here it is given which one? 3 square. 3 square will become 6 and it is 3. It will become 2. But here the 4 and it will become 4. So both will be same. You have to be very careful with this type of the questions. Last question. The energy of the electron in the first Bohr orbit of the hydrogen atom is minus 13.6. The possible value of the excited state electron in Bohr orbit of the hydrogen atom is. ఇదేం అడుగుతున్నాడు అంటే ఫస్ట్ ఆర్బిట్ కి minus 13.6 ఎలక్ట్రాన్ వోల్ట్ ఎనర్జీ ఉంటే ఫస్ట్ ఎగ్జైటెడ్ స్టేట్ కి ఎంత ఉంటది అని అడుగుతున్నాడు. The first excited state will have how much energy? First excited state will have, we know, right, minus 3.4 electron volt. So option number 1. My dear friends, by this I was ending the live session here. I hope we have did the n number of questions and we have recapped all the topics of the atomic structure which we are having. Clear? Now I hope that tomorrow you will rock your exam. Right. Good. Everyone, good. Okay. Now by this I was ending the live. Now try to balance the other subjects also. Okay. Fine. Now I was ending the live. See you tomorrow. Bye. Right. Bye, Nana. Bye. We'll see you tomorrow. Bye. Right. Okay, Sri Ganesh. Bye, Amit Dubey. Bye, Ketan. Bye, Lasya. Bye, Subhana. Bye, Janakiram. Bye, Joshita. Bye, Lasya. Right. Try to be focused. Read the questions, each and questions carefully and try to give the answers tomorrow. And try to focus the other two subjects also. Okay? And the NEET students try to focus on the other 3 subjects. Okay? Clear? Okay, bye, bye. Bye, Nana, bye. We'll see you tomorrow. Bye. Bye, bye. Bye, Leia, bye. Right, right, right.